Hi guys, you're welcome to this lesson. In this lesson, I'll be taking you through integers. In our previous lessons, we've looked at natural numbers, we've looked at whole numbers. So, if this is the first time visiting this course, kindly go back to check those videos out so that you understand the evolution of number system. In this video, there is this big question that comes in mind. So, numbers can go below 0 to, I don't know if you get that. So, can numbers go below 0 to? So an attempt of answering this question brings the idea of integers. Can numbers go below 0 to? So in the field of commerce, science and engineering evolving, there was a need for us to talk about a sense of direction opposite to the normal, and also there was a need to describe debts, losses, and others. So the concept of integers arose from around the 600 AD by an Indian mathematician, and he used the negative to describe what we call debt. So he made a statement that assets is equal to positive, then when you have a debt is equal to negative. So from then the concept of negative became very popular, and so now, so integers are generally represented by a capital Z, right, but with the leg doubled, as simple as that. So if you see a capital Z with the leg doubled, we call it what? Integers. Now why Z? Z stands for a German word called Zahlen, okay, meaning numbers in English. So that's why integers, we don't use I, unlike natural numbers and whole numbers. So it has a special origin, and that is what the Zahlen I'm talking about. Now, integers are not so different from what we've been talking about in the previous lessons. So when you talk about integers, integers are totally ordered. When I say totally ordered, what I'm trying to say is, so they are totally ordered. So now let's represent integers. Integers are said to be positive and negative whole numbers. Okay, so an integer z is equal to the sets three dots on the left side, -3, -2, -1. Then I'll have 0, 1, 2, 3, then 3 dots. Okay, so this is a set of integers. So an integer doesn't have the least number, doesn't have the minimum number, doesn't have the highest number. That is the growth. You realize that natural numbers do have a minimum number of 1, whole numbers do have a minimum number of 0, but integers do not have boundaries. So they move to the negative infinity, they move to the positive infinity. That is how we represent integers. So because of that, we can write a piecewise function as integers is given as negative, 0, then positive. So these are the three components of integers. An integer has the positive side, the 0 part, and the negative side. As simple as that. So integers are simply totally ordered. Okay, so -3 is less than -2, it's less than -1, it's less than 0, it's less than 1, it's less than 2, in that order. So it's completely ordered. With the operations used on integers, you realize that an integer satisfies 1, addition. Integers satisfy, we have multiplication. Then integers satisfy subtraction. Then but integers do not satisfy division. So still division is on standby. Now why addition? Integers are said to be closed on addition simply because whenever you add any two integers, -3 plus 5, that gives me what? 2. 2 is an integer, it's ticked. When I have multiplication, I'll say that 2 times 1, or -2 times, let's say, 6, I'll get what? -12, and that is an integer, is closed. Subtraction, if I have 1 minus 2, that gives me -1, is an integer, is closed. Now division is on standby. So you can clearly see from the evolution of numbers that the properties tends to grow as we move to the next step, and then each step covers a different thing. Now division will move out to a different number system as well. Now let's talk about something special about inverse, about integers. We call it additive inverse. Additive inverse. So when you talk about additive inverse property of integers, it means that there is a number for every number a. For every number a, there is another number which is a, negative a, so that when I add it to this number, I'll get my additive identity, which is 0. So I say it again. For every number a, there is another number which is negative a, which we call the additive inverse. So that when I add this additive inverse to the number, I'm supposed to get my identity, additive identity, which is 0. So we've also looked at additive identity in our previous lesson, which is a number. So additive identity. So this is a number which when you add to any other number within your set, you still get that same number. And that was 0 in whole numbers and 0 in integers. So additive inverse is simply you finding a number that when I add it to this number, I'll get my additive inverse. So what is the additive inverse of 12? Simply the answer is what? Negative 12. When I ask you what is the additive inverse of 15, simply the answer is what? Negative 15. As simple as that. So just have this in mind, right? Just have this in mind. So this property is exhibited only in integers. So I think at this point, I'll see you in the next lesson on rational numbers, and after we take most of the special properties one by one and go through. See you then.